Hi everyone, this video is for section 7.3 double angle identities. In this particular problem, we're given that the cosecant of x is equal to 7 and that x is between 90 and 180 degrees. We want to find exact values without solving for x. In this case, we want to find the sine of the half angle x over 2. Before we actually do that, what I want us to note here is that x is between 90 and 180 degrees. So that tells me that x is going to be in quadrant 2. But when we start to look at a half angle, we need to cut everything in half. So I'm going to take that inequality and cut it into 2. This simplifies down to 45 degrees is less than x over 2 is less than 90 degrees. So this tells me since my half angle is between 45 and 90 degrees, I'm in quadrant 1. This is going to help us indicate what signs to use when solving this problem. So in the case of the sine of x over 2, we do have a half angle identity. The half angle identity reads that the sine of x over 2 is going to be equal to plus or minus the square root of 1 minus the cosine of x, all divided by 2. Again, in this particular case, we're saying that our half angles are in quadrant 1. So that tells me that the square root that we're going to have is going to have to be positive. Okay, all because our half angle is in quadrant 1. Okay. All right, so in order to solve the half angle, or the sine of the half angle, we need to know what the cosine of x is. We don't readily have that available, but the cosecant of x equaling 7 is going to leak that information for us. So if we take a look at the cosecant of x equaling 7, what we can basically say here is I can rewrite this using my definitions. So I know that 1 over the sine of x is also going to be equal to 7 over 1. I'm just switching out what I know about the cosecant of x. I can also then go ahead and take the reciprocal of both sides. What I do to one side, I must do to the other. This is going to give me the sine of x all over 1 is equal to 1 over 7. Or in other words, if I just have it over 1, I could just say that the sine of x is equal to 1/7. So this is going to come in handy when I couple it with my Pythagorean identity. Recall that the cosine squared of x plus the sine squared of x is equal to 1. If we drop that in, we'll have 1/7 squared instead of the sine squared of x. We'll go ahead and we will evaluate, and that's going to give me 1 over 49 is equal to 1. We want to start getting the cosine of x alone, so we'll have the cosine squared of x is equal to 48 divided by 49. From here, we're going to take the square root of both sides. And lo and behold, we see that the cosine of x is going to be equal to plus or minus, and I'm going to do this on purpose just as a review. Remember that we could break that square root into one for the numerator and one for the denominator. So note here again, we have to make a decision about what sign to use. Since we are working with x, x is telling us that we are in the second quadrant. And what do we know about cosine values in the second quadrant? Hopefully you're telling me they're negative. So if I clean this up using my Math 98 info, I know that this becomes the negative 4 root 3 all over 7. Okay. So now I can go ahead and use my half angle identity. We have the sine of x over 2 is equal to the square root of 1 minus a negative 4 root 3 over 7, all of which is over 2. that looks pretty nasty. But let's go ahead and break it out of that shorthand. So in other words, notice how everything is over a 2. So I'm going to rewrite this so that this is a 1/2. Since I do have a minus minus, I'm going to have a plus 4 root 3 over 7 all over 2. This is still a complex fraction, and we have looked at how to solve these before, but I do want to include a shortcut here. So what I want to note here is that I have 4 root 3 over 7, and that's all being divided by a 2, or in other words, a 2 over a 1. Okay, so please bear with me as I continue with this. So the shorthand is basically saying, remember that this is essentially a division. We're saying this is 4 root 3 over 7 divided by 2 over 1. Well, we skip the first one and we flip the second fraction. So essentially then what we're saying is the top is going to interact with the bottom of the other fraction, and the bottom will interact with the top. So this is going to simplify down as follows. We'll have our 1/2 plus, we'll have 4 root 3 times 1, so this will be just 4 root 3, all divided by, and we have our 7 times our 2. So that'll give us our 14. We can simplify this down a little bit further as follows. So this is going to be equal to 1/2 plus, and the 4 and the 14 will reduce, so this is 2 root 3 all over 7. So this is the exact solution for the sine of x over 2. Let's go ahead and go a little bit further with this. And we're going to work to solve the cosine of x over 2. Okay. We also have a half angle identity for this one. We know that the cosine of x over 2 is equal to plus or minus the square root of the cosine of x plus 1 all over 2. Again, we do need to address which sign to use. We said that our half angles in this particular problem are all located in the first quadrant. So that means that they'll both be positive. We also know from our previous work that the cosine of x is equal to a negative 4 root 3 over 7. So let's go ahead and drop that in and see what we get. So we have the square root of our negative 4 root 3 over 7, so that's taking the place of that cosine of x, plus 1, all of which is being divided by 2. Again, we have a really nasty looking problem here. So the first thing that I'm going to do is I'm going to take it out of its shorthand. So we have negative 4 root 3 over 7 divided by 2. I'm going to put that over a 1 just to kind of get ahead of myself, plus a 1/2. Again, based off of that shortcut, we can multiply top with bottom and then bottom with top. Okay, and if you don't believe me, please go ahead and please pause the video and do this a little bit. Use the longer hand version of this and see if it comes out to be the same thing. So this is going to end up being equal to, so negative 4 root 3 times our 1 will just give us negative 4 root 3, and 7 times 2 gives us our 14, plus 1/2. And then we can simplify that down, and this becomes the square root of negative 2 root 3 over 7 plus 1/2. But just for the heck of it, and kind of to get ahead of myself, I'm going to rewrite this. So I'm going to use my commutative property and write this as 1/2 minus 2 root 3 over 7. So it does kind of match and mirror what we had in our work above. Okay, so let's go ahead and tackle the last problem. the last problem in here for part C is we want to find the tangent of the half angle. We don't have an explicit identity for it, but we do know that this is the same thing as the sine of x over 2 divided by the cosine of x over 2. Okay, and we have that information. So we know that this sine of x over 2 is going to be the square root of 1/2 plus 2 root 3 over 7. And we know that this is the square root of 1/2 minus 2 root 3 over 7. Okay, so bear with me on this one. We have the solution. It's right here in front of us. And if we just needed to do a decimal approximation, you could go into your calculator and just type all this in and get that decimal. I'm going to show you the exact value, so please bear with me. It's a lot of manipulation. So one of the first things that I'm going to note is that I can get a common denominator here. That common denominator, given the fact that both of them have a 2 and a 7, is going to be 14. So if I rewrite this problem, and actually what I'm going to do is I'm also going to write this back over one giant square root. This is going to give me 7 plus 4 root 3 all over 14. And that's going to be divided by 7 minus 4 root 3 over 14. Notice that they both have denominators that are 14. And again, based off of what I know, I guess I'm getting ahead of myself, so I'll show that. Is again, I can top interacts with bottom, and bottom of the fraction interacts with top. So this is going to look like the following. I'm going to have 7 plus 4 root 3 times 14, all divided by 7 minus 4 root 3 times 14. As you can see, these will cancel each other out now. And I'm left with the following solution. 7 plus 4 root 3, all divided by 7 minus 4 root 3. Again, I'm going to do a little bit more manipulation because I don't want to necessarily have like a radical inside of a radical. So what I'm going to do is I'm going to multiply both sides by a 7 minus 4 root 3. And you'll see why in a moment. And it's actually going to be its own radical. So it's all going to be underneath one big square root. So if we FOIL this, we'll get the square root of 49 minus 28 root 3 plus 28 root 3. And then if we do 4 root 3 times 4 root 3, that's going to give us a negative 4 root 3. That's going to give us a negative 48. Okay. This is going to be all over. I'm going to save myself a little bit of pain here and kind of say this is 7 minus 4 root 3 squared, since I am multiplying the same thing together. So notice what happens here. The negative 28 root 3 will cancel with the positive 28 root 3. And this will give me 49 minus 48 all over 7 minus 4 root 3 squared. Let me just break this up. So this is going to give me the square root of 1 over the square root of 7 minus 4 root 3 squared. Square root of 1 is just 1. And the square here and the square root are going to cancel each other out. So this gives me 7 minus 4 root 3. I know that it's usually bad form to leave any sort of square root in our final solution, but I am going to leave it here. And again, please note that if you were able to follow this process, most likely WAMAP is going to ask you to present your answer using decimals, not necessarily exact values. But I figured this video was a nice challenge, but it also gave you a nice layout of the process. If you do have any other questions, please let me know.